opposed to the other speakers, I am not an operator, never been an operator, and although I am a customer of operators. But I guess I think I'm also at the wrong conference. I just spent a year in DC, and I thought this was statutory delayed networking. Because in DC, it seems they just want to keep passing laws on how we're not going to deploy networks, as opposed to actually, and it's actually refreshing to see folks that are working to actually deploy things. So I want to mention, or what I was going to talk about, and I will get to why I'm excited about SDN and what do we need for it. But sort of lessons learned. We just finished a project from the White House called the Smart America Challenge. The goal of the project was to show what's accomplishable with cyber-physical systems. So first, how many people have ever heard of cyber-physical systems? Okay, a couple of folks. Therein lies a major problem. The government's invested about $600 million in cyber-physical systems. What most of you would think of as the Internet of Things is sort of like cyber-physical systems, but let me try to tell you the difference. The Internet of Things is Waze. It tells you where your car is on the road. Cyber-physical systems controls the street lights so that when there's no one else at a traffic light, you don't have to stop. A cyber-physical system, if we take it to its logical conclusion, hopefully, it actually controls your brakes. It controls the car. It just doesn't tell you where you are. That's what the Internet of Things does. It actually gets into the point of where it's controlling the brakes on your car. Why is that interesting for SDN? Well, if you don't have some sort of high confidence networking, generally the packet to apply your brakes comes 1 second after you hit the car in front of you, and that's generally not a good thing for any of us. So the other point of the Smart America Challenge that we did was it wasn't about technology. It wasn't my protocol is bigger than your protocol. It was about how do the protocols actually, how does the technology actually get delivered and create benefits to American society? The President, the White House wants to know, how are we going to create new jobs? How are we going to reinvigorate the American economy? So when we went out to all the companies, we said, don't just talk about my protocol or try to sell a protocol. Instead, tell us how this is actually going to create jobs. So we ran this for a year. And last June, well, first what we did is we went out to America and we said, if you have a test bed, if you're working on CPS, come together, bring your Lego piece, let's attach it to something else, and let's see what we can make out of it. Let's see if we can take a test bed that works in healthcare and attach it to something that works in the energy market and do something different than what they were doing before. Because what we found was folks in healthcare looked at their application and said, those guys over in energy have no clue what we need out of our application. Or the guys in energy said, transportation, our network is totally different. We need something else. When we brought them together, they realized there were a lot more commonality, and a network sort of is a network is a network. At the end of the day, nothing against Comcast and everybody else, a bit is a bit is a bit. It doesn't matter whether it's a video bit, it doesn't matter whether it's a voice bit, it doesn't matter whether it's a data bit, it's still a bit. And so for a lot of these folks, it was a huge realization that everybody's idea of real time isn't quite the same, but they're somewhat similar. At the end of the day, we had 24 projects that were launched, 100 different organizations, including folks we started with National Lambda Rail. Hopefully you heard of them. They're gone. Internet 2 and US Ignite came in, and that's sort of where some of the software-defined networking came from. Oh, the other thing I want to, Geoff mentioned, what do we need for deployment? V6, 4%. I think it's an interesting statistic. I was asked that the other day about, well, the deployment of V6 is only 4%. And it's actually, well, that's the traffic, right? The thing that's interesting is when we talk about the Internet of Things, these devices aren't going to talk a lot. A temp sensor, frankly, doesn't have a whole lot to say. It says it's 72 degrees and goes back to sleep for an hour. So as the Internet of Things gets deployed, it's not going to drive a huge amount of traffic. It'll drive a whole lot of addresses, but it's not going to drive necessarily a whole lot of traffic each and individual device. Hopefully in aggregation, 20 billion devices, I think Cisco says by 2020, that might be a bit more traffic. But each individual device does a sensor require SDN? Heck no, right? If it's trying to tell the temperature, it'll get there, and that's good enough. If it misses a packet, not a big deal. But as you have 50 billion devices or 20 billion devices, suddenly SDN-type things become much more important. So what were some of the takeaways? from, we out of these 24 projects, we actually had deployed systems that worked for, on things like smart emergency response. How do we redevelop an interaction between robots, drone networks, human operators? We had sensor-enabled search dogs. How do those all fit together? What we come to find out was we didn't necessarily need to invent a whole lot of new protocols in order to start to deploy some of these things. Whether they were sensor networks that were doing air quality monitoring, whether they were sensor networks doing traffic control in southeast Michigan. There's a test bed with 2,800 cars driving all over. Fact is, those things are out there today. But what we did find that we're interested in as far as the next deployment, and where I think SDN is going to help drive, is something that we were terming high confidence networking. And what we mean by that is a network that has improved security, not perfect security, but certainly something more improved. You don't want someone to send a packet that just causes everybody's brakes to go on, or even just their brake lights can be a bad thing, or turn on their windshield wiper while you're driving down the road. That might be a little disconcerting. Also improved determinism. Hopefully everyone understands in networking there is no such thing as perfect determinism unless maybe you just have one wire and two end nodes. But if you talk about a large mesh network or a large type of network, and especially in wireless, there is no such thing as perfect determinism. But I think SDN and some of the developments that are coming along can improve determinism. And probably the most important for cyber-physical systems and for the Internet of Things is something called bounded latency. We don't need guaranteed latency, but we need some upper bound on understanding when I drop a packet in the network, when is it going to reach, when can I sort of be assured that it's going to reach the other end. Today, we're all pretty good. Something doesn't go through, and you sit there and you hit, you hit return or you reload the page or whatever, and the page finally comes back. That's okay, but if it's your car, that's not a good thing. You don't hit Control-Alt-Reboot, Control-Alt-Delete to make sure that your packets are getting through. So having some sort of bounded latency is important. So as chairman of IPSO, IPSO is the IP for Smart Objects Alliance. We are out pushing the concept of IP to the very edge of the network. Let's get rid of gateways. Let's get rid of translation, because translation causes a problem. You no longer have end-to-end security. You don't have bounded latency. You've added sort of things in the middle that hurt determinism and all of that. So from an IPSO point of view, we want IP end-to-end. I'm excited by SDN because I think that the programming, the experimentation that you guys were talking about earlier, like Cisco or like Comcast is doing, trying some new protocols, try a slightly different tweak on IS to IS, is a great thing. And I think that we can test it out here and then start to apply it to other things, because wireless, part of the area that I've been working in for the past 10 years is wireless sensor networks. And we've only just begun to realize what I think is now starting to be developed and deployed through SDNs is a separation of the control plane and the routing plane, or from a wireless sensor network, the separation of the forwarding plane from the routing plane, where routing gives you a hint on where to send the next packet, but it actually gets forwarded at a slightly different level. Because in wireless sensor networks, unlike wired networks, the connectivity changes on potentially a millisecond basis. With a wired network, you generally don't unplug wires on a millisecond basis and change where things are going. Maybe with SDN, you start to do that. But in a wireless network, someone closes a door, someone turns on a microwave, someone starts another router, your connectivity changes, and the noise of the network changes almost instantaneously. And so as a result, this idea of having these routing protocols that work on second basis or 10-second basis is trying to understand where do you forward the next packet doesn't make sense in WSNs. And so the experimentation, the stuff that's coming out through SDN, I think is going to be hugely beneficial. So then lastly, I was thinking, I had an idea while Geoff was talking, how can we get more V6 deployment? And I thought, I've often said to Google should just become V6 only. Boom, the whole internet would be V6 tomorrow, right? Well, and then Google said, fine, pay us like $10 million or $50 million a day and we'll be V6 only because that's how much revenue we'll use. So I thought, oh, maybe that won't work. I had the idea, why don't we all just write to Netflix and say, Orange is the New Black can only be accessible through V6. Boom, everyone will go to V6 the next day. That's all I've got. Thank you.